There is a moment roughly 2 million years ago that nobody witnessed, but that changed everything. A hominin, not yet fully human, not the knuckle-walking ape of a few million years before, but something in between, something becoming, is standing at the edge of a kill site. The kill was not theirs. A pride of lions took down a large bovid sometime in the previous hour, fed, and moved on, leaving the carcass in the condition that large predator kills leave carcasses. Significantly opened, with the primary organs and large muscle masses consumed, but with substantial remaining material that the lions will not return to in the immediate term. The hominin approaches, not quickly, with the specific, careful assessment of risk that characterizes an intelligent animal moving towards something valuable in a landscape full of things that might want to take it from them. They look at the carcass, they look at the bone, the large dense femur of the bovid, still articulated, still containing something that the lions did not access and cannot efficiently access. And then they do something that a lion cannot do, that a hyena cannot do despite their famous bone-crushing capability at certain scales, that essentially no other animal in this landscape is equipped to do in the specific way this hominin is about to do it. They pick up a rock, and they use it. The marrow comes out. Dense, fatty, calorie-rich marrow. The specific nutritional payload that this specific technology was evolved to access. And the calories in that marrow will, over a long enough timeline of repeated events like this one, contribute to something extraordinary. The growth of a brain that is metabolically expensive beyond almost anything else in the animal kingdom, that requires sustained caloric investment to develop and maintain, and that will eventually produce the species sitting here today watching a video about how it came to exist. Animals did not just coexist with ancient humans, they shaped us in ways that are specific, documented, and genuinely profound. Let's start with the most fundamental and most debated mechanism, the role of animal protein in the expansion of the ancient human brain. The human brain is, by any biological measure, an extraordinary organ. It constitutes approximately 2% of body weight, but consumes approximately 20% of the body's caloric budget at rest. That metabolic cost is staggering. The energy required to run a fully developed human brain is so high that it imposes genuine constraints on every other energetically expensive system in the body. The specific trade-offs that human evolution made to afford the large brain, reduced gut size, reduced muscle mass relative to other primates, specific metabolic efficiency changes, all reflect the specific demand that brain development imposed on the ancient human energy budget. For the brain to grow across the span of hominin evolution, from the approximately 400 cubic centimeter brain of Australopithecus to the approximately 1,400 cubic centimeter brain of modern Homo sapiens, the available caloric supply had to expand correspondingly. The brain did not grow because the caloric supply was already available. The caloric supply had to increase for the brain growth to be sustainable, and the specific caloric expansion that fueled hominin brain growth was, in significant part, animal-derived. The specific nutritional profile that animal products provide: high-quality complete protein, omega-3, and omega-6 fatty acids in the specific ratios required for neural tissue development, bioavailable iron and zinc, and B12, in forms that plant foods cannot efficiently provide, maps almost perfectly onto the specific nutritional requirements of building and maintaining a large brain. The neural tissue that a large brain consists of is primarily fat, specifically specific long-chain fatty acids, including DHA, that are abundant in animal products, and that plant sources provide only in precursor forms that the body must convert with limited efficiency. The expansion of animal product consumption in the hominin diet, the shift from a primarily herbivorous diet toward the omnivorous, animal-heavy diet that archaeological evidence documents in Homo habilis and especially in Homo erectus, is directly correlated in the fossil record with the acceleration of brain growth. The causal relationship is not perfectly established. Correlation is not causation in evolutionary biology any more than elsewhere. But the nutritional logic is compelling, and the temporal correlation is striking. Animals, by being food, fueled the brain that eventually thought about what animals were for. Let's talk about the specific technology that access to animal resources drove, because this is where the evolutionary feedback loop gets interesting. The Oldowan stone tools found at sites dating to approximately 2.6 to 2.5 million years ago, the oldest confirmed stone tools in the archaeological record, were used in significant part for processing animal carcasses. The specific wear patterns on Oldowan tools and the specific cut marks on animal bones found at Oldowan sites tell a consistent story. Ancient hominins were using stone tools to access the flesh and marrow of large animals that they were either hunting or scavenging. Here is the evolutionary feedback loop that this establishes. Access to animal resources required tool-making capability. Tool-making capability required cognitive investment in planning, spatial reasoning, and the specific fine motor control that napping stone requires. The caloric return from the animal resources that tools enabled provided the nutritional substrate for the brain development that better tools required. Better tools enabled access to more and better animal resources. More and better animal resources funded more brain development. This is a co-evolutionary feedback loop in which animals and ancient human cognition were reciprocally shaping each other, not through any intention on the animal's part, obviously, but through the specific ecological dynamics of a species that was both prey and predator in a landscape full of animal resources that were metabolically critical for its specific evolutionary trajectory. The specific cognitive demands of hunting and scavenging large animals extended far beyond the mechanics of stone tool production. Large animal hunting requires a specific suite of cognitive capabilities that simple plant gathering does not. Spatial reasoning about animal movement and territory, theory of mind applied to prey behavior modeling, coordination of group action toward a shared goal, planning across time horizons that extend beyond the immediate moment, and the specific executive function required to maintain a complex strategy across an extended and unpredictable encounter. These cognitive demands, imposed by the specific challenge of reliably accessing large animal resources in competition with other capable predators and scavengers, are the specific evolutionary pressures that the cognitive evolution of the human lineage was navigating. Animals, by being difficult to hunt effectively, selected for the specific cognitive capabilities that eventually made ancient humans the most cognitively sophisticated organisms on Earth. Let's talk about cooking and its specific relationship to the animal-human evolutionary story, because cooking is one of the most underappreciated drivers of human evolutionary change, and its connection to animal consumption is direct. The anthropologist Richard Wrangham's cooking hypothesis proposes that the controlled use of fire to cook food, specifically animal food, was the specific technological development that enabled the final large expansion of the human brain and the specific reduction in gut size that distinguishes modern humans from earlier Homo species. Cooked meat provides dramatically more bioavailable calories than raw meat, requires significantly less digestive work, is safer from pathogens and parasites, and can be stored for longer before spoilage makes it inedible. The specific anatomical changes associated with cooking in the human lineage. Smaller teeth, smaller jaw musculature, smaller gut, specifically the reduction in the length of the small and large intestine, all reduce the energy cost of the digestive system, freeing metabolic resources for brain development. The timing of these anatomical changes correlates with the evidence for fire use in the ancient record in ways that are consistent with Wrangham's hypothesis. What this means for the animal evolution question is specific. Animals, by being food that was nutritionally transformed by cooking, drove some of the most significant anatomical changes in human evolutionary history. The reduced gut of modern humans, which is smaller than the gut of any other primate of comparable body size, is partly a consequence of the specific caloric efficiency that cooked animal food provided. The human body, over generations of consistent cooked animal food consumption, reduced its investment in the digestive infrastructure needed to process raw plant foods and redirected that energy toward brain development. We are literally shaped differently, at the level of our anatomy, by the fact that our ancestors ate cooked animals. Let's talk about something that is less often discussed, but equally important: the role of specific animal behaviors in ancient human cognitive development. The observation of animals was a primary intellectual activity for ancient humans. Not casual, background observation, sustained, systematic, empirically rigorous observation that was both survival critical and cognitively demanding in ways that we consistently underestimate. Understanding the behavior of large prey animals, their movement patterns, their social structures, their responses to specific stimuli, their vulnerabilities, and their capabilities required building detailed mental models of how those animals worked. These mental models were causal, predictive, and updatable, the same basic cognitive operations that underlie scientific reasoning. The ancient hunter predicting where the herd would be tomorrow based on observed patterns of movement today was engaging in hypothesis formation and testing. The hunter who noticed that specific weather conditions produced specific prey behavior changes was building empirical models of correlation and causation. The specific cognitive capabilities required for this kind of systematic animal behavior modeling, sustained attention, attention, pattern recognition across time, causal reasoning, predictive modeling, updating of models in response to new information, are the same cognitive capabilities that underlie the most sophisticated human reasoning in every domain. They were being exercised and selected for, generation after generation, in the context of the specific challenge of understanding and predicting animal behavior. Animals, by being complex and interesting and important to understand, were providing the specific intellectual challenge that drove the development of the cognitive capabilities that eventually produced philosophy, science, mathematics, and every other domain of sophisticated human thought. The ancient hunter thinking about where the reindeer herd would be in 3 days was the cognitive ancestor of the astronomer predicting where a planet would be in 3 months. The same mental operations, applied to different problems. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content, covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Let's talk about parasites and disease, because this is the most uncomfortable dimension of the animal-human evolutionary relationship, and the one that most directly shaped human immune biology in ways that are still relevant today. Ancient humans living in close association with animals, hunting them, scavenging their carcasses, eventually domesticating them, were continuously exposed to the specific parasites and pathogens that animal contact transmits. This exposure was not trivial. Parasitic load was a significant mortality source in ancient populations, and the diseases that jumped from animal hosts to human hosts, the zoonotic diseases, were the specific disease threats that shaped the human immune system most powerfully. The immune system of modern humans is specifically calibrated to the specific threat landscape that ancient humans navigated through their animal associations. The specific pattern of innate and adaptive immune responses, the specific range of pathogens that the human immune system is calibrated to detect and respond to, the specific genetic variants in immune-related genes that modern populations carry, all of these reflect the selective pressure of the specific disease threats that ancient animal contact imposed. This is not simply a story of animals harming ancient humans through disease. It is a story of co-evolutionary dynamics in which animal pathogens and the ancient human immune system were in ongoing evolutionary dialogue, each adapting to the other in ways that produced the specific immune capabilities of modern humans. The resistance variants that humans evolved in response to specific animal-transmitted diseases are part of the evolutionary legacy of ancient human-animal association. The specific immune advantages that some populations carry, resistance to certain parasites, resilience against certain pathogens, are directly traceable to the specific animal contact patterns of their ancestors. Human immune biology is, in significant part, a product of what animals did to ancient humans across the long co-evolutionary history we share with the animals of our landscape. Let's talk about the social cognition dimension, because this is perhaps the most fascinating and least discussed mechanism through which animals shaped ancient human evolution. Human social cognition, the specific capability to model the mental states of other individuals, to understand their beliefs, desires, intentions, and perspectives as distinct from your own, is the most distinctively human cognitive capability we have, and the one most directly responsible for the specific character of human social life. Theory of mind, as it is called in cognitive science, is the cognitive foundation of language, of culture, of cooperation, of everything that makes human social life different from the social life of every other species. The development of sophisticated theory of mind in the hominin lineage was almost certainly driven in significant part by the specific cognitive demands of understanding and predicting animal behavior. Modeling what an animal will do next, what it perceives, what it intends, what it fears, what will cause it to flee or charge or freeze, requires applying something very like theory of mind to non-human subjects. The ancient hunter who was modeling the mental state of a prey animal, understanding that the animal did not perceive the hunter in the downwind approach, anticipating the animal's response to specific stimuli, planning approaches that exploited gaps in the animal's perceptual awareness, was exercising theory of mind in a directly survival-relevant context. The specific cognitive machinery developed for modeling animal minds would then have been available, with modification, for modeling human minds, for the sophisticated social cognition that characterizes human interpersonal relationships. The theory of mind that makes complex human social life possible may have been partly bootstrapped from the theory of animal mind that ancient hunters needed to navigate complex hunting challenges. Animals, by having minds worth modeling, may have contributed to the development of the cognitive capabilities that allowed ancient humans to model each other's minds with the sophistication that human social life requires. Let's talk about the dog relationship specifically, because while we have covered it in other contexts, its specific evolutionary significance deserves direct attention here. The domestication of dogs from wolves approximately 15,000 to 40,000 years ago, the date is debated, represents not just a human adoption of a useful animal, but a genuine co-evolutionary event in which both species were changed by the relationship. The evolutionary changes in dogs are better documented. The selection for reduced human reactivity, for specific social cognitive abilities applied to human behavior, for the specific suite of traits we associate with domestic dogs. But the evolutionary effects on humans are real as well. Humans with dogs had access to a specific set of capabilities that humans without dogs lacked. Enhanced hunting efficiency through tracking and pursuit assistance, enhanced camp security through early warning, enhanced foraging efficiency through the scent tracking capability that dogs brought to the foraging context. These capability enhancements translated into caloric advantages. More efficient hunting meant more reliable access to high-quality animal protein. That fed back into the human developmental advantages we have been describing. But there is a more specific and more interesting evolutionary effect. The development of the dog-human relationship selected for specific human social cognitive capabilities applied to cross-species communication. Humans who were good at reading dog behavioral signals, at understanding dog communication, at communicating their own intentions to dogs in ways dogs could understand, at forming and maintaining the specific cooperative relationship that made human-dog partnerships effective, were humans who had enhanced hunting success and survival. The specific social cognitive capabilities required for effective human-dog communication were being selected for in ancient human populations as part of the functional package that made the human-dog partnership work. The result is that modern humans show specific cognitive capabilities for cross-species communication, for reading animal behavioral signals and responding appropriately, that are more developed than would be expected from an exclusively human social cognitive adaptation. Our ability to read dog expressions, to communicate with dogs effectively, to form genuine affective bonds with non-human animals. These capabilities were shaped by the specific evolutionary pressure of making the human-dog partnership work effectively across thousands of generations. Let's talk about migration and range expansion, because animals shaped the geography of ancient human evolution in ways that are often overlooked. The specific animals available in different environments were a primary determinant of whether those environments were habitable for ancient humans in any given period. Environments rich in large game supported ancient human populations. Environments from which large game had been depleted through climate change, previous overhunting, or ecological collapse did not sustain ancient human populations well. The distribution of huntable large animals across the ancient landscape was a primary driver of ancient human migration and population distribution. The seasonal migrations of large herd animals were specifically tracked and followed by ancient human populations across vast geographic ranges. The reindeer migrations of northern Eurasia, the wildebeest migrations of eastern Africa, the mammoth movements of the Eurasian steppe. These animal movements defined the temporal and spatial organization of ancient human settlement patterns. Ancient humans did not choose where to be based on their own preferences in any modern sense. They followed the animals because the animals were where the calories were. This animal-following migration pattern exposed ancient human populations to the specific environmental challenges of a wide range of ecological zones. Different climates, different landscapes, different seasonal extremes that drove the specific adaptive responses documented in modern human genetic and physiological diversity. The thermal adaptations of Arctic populations, the high-altitude adaptations of Tibetan and Andean populations, the specific immune adaptations of populations exposed to specific regional disease environments, all of these are partly products of the specific environments that following animal resources drove ancient humans into. Animals, by migrating, took ancient humans with them, and the specific environments those migrations led ancient humans into shaped the specific physiological and genetic diversity of modern human populations. Let's address one more mechanism that is genuinely fascinating, and that represents perhaps the deepest level at which animals shaped ancient human evolution: the role of observing animal social behavior in the development of ancient human social structures. Ancient humans observing wolf pack dynamics were observing one of the most most sophisticated social structures in the non-human animal world. Coordinated group hunting, hierarchical but flexible social organization, cooperative pay-up rearing, the specific territorial and social intelligence of a highly social predator. They were not just observing a useful animal. They were observing a sophisticated social system that solved many of the same problems that ancient human social organization needed to solve. The observation of animal social behavior, how herds organized their movement decisions, how primate troops managed internal conflict, how wolf packs coordinated group activity, was not merely interesting to ancient humans. It was informationally relevant. Ancient humans trying to solve the problems of cooperative group action were observing other species that had solved similar problems with their own specific solutions. The specific insights gained from sustained animal social observation were almost certainly incorporated into the evolving social intelligence of ancient human communities. This is not conscious cultural borrowing. Ancient humans were not deliberately adopting wolf pack social structures for their own communities. It is the more subtle and more powerful influence of sustained observation of alternative social solutions on the developing social cognition of an intelligent species working on the same problems. Here is the full picture that emerges. Animals shaped ancient human evolution through every mechanism available to an ecological relationship of sufficient depth and duration. They provided the specific nutritional substrate that fueled brain growth. They imposed the specific cognitive challenges that drove the development of planning, prediction, and theory of mind. Their pathogens shaped the ancient human immune system through co-evolutionary dynamics that produced modern immune capability. Their behavior provided the cognitive exercise that developed the reasoning capabilities that eventually produced human science and philosophy. Their domestication drove the selection of specific human social cognitive capabilities applied to cross-species communication. Their migrations drove ancient human populations into the specific environments that produced the physiological and genetic diversity of modern humans. We did not evolve in isolation and then encounter animals. We evolved through our relationship with animals, shaped at every level by the specific ecological dynamics of sharing a world with creatures that we hunted, feared, watched, followed, lived alongside, and eventually called our own. The hominin at the kill site, using a stone to access marrow that will eventually fund a brain capable of understanding its own evolutionary history. That moment is not the beginning of the human-animal relationship. It is a moment in the middle of a relationship that has no clear beginning, that extends backward into the deep evolutionary past, and that continues forward into every dimension of what modern humans are. Animals made us. Not in the design sense, nobody planned this. In the ecological sense, through the specific pressures, the specific resources, the specific challenges and benefits of the relationship that shaped our bodies, our brains, our immune systems, and our cognitive capabilities across millions of years of shared evolutionary history. The debt is extraordinary, and it is, in the most literal biological sense, written into everything we are.